Hello, welcome to this lecture. In this lecture, we are going to talk about an example of a monolithic application and what are the impacts of it. The goals for this lecture is first to think about how we can customize our elements, how we can customize our application. We are going to talk a lot about modularity, and we are going to analyze an example, a real example from Squeak and its implementation in Faro. We are going to analyze how we handle preferences and optional configuration in Faro and in Squeak. We have, in both cases, we want to have a way of configuring our system, configuring our tools to work in the way that we want. So in both cases, we have a setting browser where we can set all the customizations, all the settings that we want for our tools. For example, the colors, the direction of the text, the fonts that we are using, the size of those fonts, and all these settings are applied on our tools. So what we want to do is basically to have a way that we can configure our application to work in the way our preferences say it. And what we want to have only one way of handling this dependency in all the systems. So we give a single entry point to the user, how to configure the system, but also how to use it from the developer point of view, how to use the setting system. So we want a modular definition of the preferences, so we have them in a single point. We also want that our objects, our domain object, does not have a dependency with the preferences, because every time that we modify the preference or modify our objects will affect on another part of the system, and that is not desirable. So how we can do this idea of having a detached mode, a detached preference module, and also still having the ability to change the behavior of our application. Let's look the first solution that we have to analyze. In Squeak 3.8, there was already a solution to this problem. There was an object that called preferences that was basically a facade for managing these preferences. This is a bad design pattern, but we are going to describe it now. Why is it? Basically, this object preferences was referenced by other elements in the system in a total of 617 times. So all over the system was using this preferences class. So it ended being a really huge dependency of everybody. Everybody, doesn't matter what you are doing, were using this preferences class. If you are reading a PNG or compiling a method, you are using the preferences class. All the subsystems were basically having a dependency to this preferences class. For example, if we have a morph that represents, a morph is a graphic element in Faro and Squeak, but let's say a graphic element that represents a menu. Well, does this menu have round corners or not? Well, that is a preference. So if we was using or not round corners, was delegating this question to the preferences class. Other part, a button that we have, and it should or not use a standard font or have a specific font. Which is the font to use? Well, again, we ask to the preferences. This is, you can tell me, okay, in this kind of problem, we have the UI elements asking to the preferences. We have a dependency between the UI elements and the preferences. Okay, can be good, but this also happens in a core part of the system. For example, when we were printing the template for creating a new subclass of a given class, we had also a reference to the preferences class asking if we are use a type of syntax or an alternative one. Another example, in this case, in the input sensor. The input sensor is the object that take care of handling the events of keyboards and mouse. And in this time was asking if we have to swap or not the Alt key. And look, again, we have a dependency with the preferences class. So a lot of part of the systems were were pointing to this preferences class. So we have basically that a lot of modules of the system. We have our UI modules, but our compiler, our input handlers, everything was passing through the preferences. We have that this preference class was referenced all over the system. If I have to add a new preference, a new alternative of configuration, I have to touch the same preferences class. As we see, all the components in the system were depending on this preferences class. So we have a dependency of mostly everybody on preferences. We cannot remove this class. We cannot remove the preferences system because it's not optional. Everybody depends on it, is this point. If everybody depends on it, we have to have it always. And every time we add a new dependency on it, we made that this new component also depends in all the other components in the system. Because remember that if we have one component, the UI, and this one has a dependency on the preferences, and we modify the preference to add a new value, for example, now that it will be used by the proxy, the HTTP proxy, we add a new thing here. Now we have added also a dependency to our HTTP proxy. So in an indirect way, we end having a dependency between these two modules that does not have nothing to do one with the other. Clearly, we are in a really bad situation, and we end with a really heavy monolithic system. So in this example, we can see clearly that the combination of facade and singleton are really bad for having a modular system. Usually we should say that a facade should basically never be used, or rarely if we are nice enough. Because it's a good idea that propose a single point of entry, but this idea is only applicable in little scenarios. Also, a facade is always disguised as a global variable, and we already have talked in this what is the impact of having global variables and how they are bad for modularity, the ability to write tests for it, and a global variable is usually not recommended. You can see also the lectures about singleton to see more and understand when is correctly to use this and when is correctly to use the idea of global variable. But in mostly of the scenarios, we are with a smell, a code smell, what we say, because this shows a potential problem. So what is an alternative to this? Well, what we want to do is that the modules or the components that have parts that we can customize, that we can set by settings, we'll expose them via methods in its own declaration. We will see this in more clear with an example. The class of the component that we are configuring will declare which are these points of customization. Then with this declaration, we can generate the UI for the user. And once the UI is modified by the user, we can configure the resulting objects. What is the idea? the idea is that, for example, if we need to have in our previous example of the menu morph, we have to have the option to have or not round corners. What we are going to do is add a class instance variable or a shared variable with this value stored. So we don't need to ask here the preferences. The same for the basic button to get its own standard font. It will ask it to itself or it will ask it to its class, but always inside the module. The menu morph will use a shared variable or an instance variable that is defined inside the menu morph. This sounds really obvious, and it sounds that is the really great idea to do, but in the beginning it's not so evident. So an object, we have to design it to be customizable. We need to put the points of extension that we want, and we need to think when these are modified and what are the state that we can customize. And of course, this state should be always internal to the object. As I said before, for example, in the case of the menu morph, the variable should be in the class menu morph or really close to the class menu morph. Let's see an example of how to implement it more correctly. We have a shop progress bar morph. It's a UI component that shows a progress bar. Basically, it's a square that has a label and a bar that gets filled as long as we are finishing the task that we are finishing. It's a progress bar. We have an option in this progress bar that affects all the progress bar that can be interruptible or not. We can interrupt this process. Basically, we have a flag. We want a flag to have a button here to cancel the job that we are doing, cancel the action that we are doing. Okay, this is something that we want to configure because depending on the system, the application that we are building, we want it to have it or to not have it the button. So how we do this? Well, in the class side of the shop progress bar morph, we are going to add a new shared variable that is called isInterruptible. And we are going to give it to it with the lazy initialization a default value. Then, of course, we are going to add to be accessible a nice accessor is interruptible, and also we are going to add an instance side element to access the same accessor. Now, when we want to decide or not to draw the button, the interruption button, we are going to ask directly to self. As we see, the configuration is doing what we ask. Is inside the shop progress bar morph. In this time is in the class side, but is in the same class, and we are using it accessing directly with self, so it's local to our class. Once we do that, we have to declare that we have a point of extension. How we do that? Well, we are going to add a new method in our class side that will have the name that we want, but it's important that receives a new argument that is the builder, the setting builder. This setting builder is what we are going to use to configure how we want to present it to the user. The idea is that we want to present it to the user with a checkbox. So we have to give to this checkbox the text that we are going to have, the description, that is the text that will appear when the user put the mouse on top of it, and what is the value that we are going to change when it's clicked or not. This is done by this builder of settings. As you see, we are talking about the property is interruptible. We are giving a default value. We are giving the description and the label. So In this way, the class showProgressBarMorph is describing to the settings how to expose the settings, and this code is only called, this message is only sent when the settings needs to create the window. If we don't have a setting window in the system, if we remove the settings package from the system, all the module, this message will never be called. This message will never be sent, and this method will never execute, and we don't have now a dependency. We have a really slight dependency. This is the once we described how to present the setting to the user, we can see that now the setting browser can take that information and generate in the correct place, that is where we describe it, the checkbox so the user can set or not the value. As we see, let's see a little more about the architecture that we have. We have a really layered architecture where we have splitted the responsibilities. In one way, we have a setting browser that is our UI. This setting browser will collect all the methods that in this case will collect it using a technique using this pragma, but is anecdotic. But it will collect all the methods that describes the settings, and will send this message to each of them to get the description of the setting to show. The domain, as we see here, is clearly separated, and the domain will use its internal customization hooks. It will use its internal state to customize itself, and it will declare these customization hooks to the settings. So we have a really smaller dependency between these two components. We have simplified the dependency. So it's important that we see two different concepts in this. One is that we want that our modules have a layered dependency. We don't want all the domain depends on a specific tool, or in this case, the setting framework. We want our domain of application, our solution to the business problem, not to depend on the setting framework, because we are not mixing layers. So also, the settings, the descriptions of the settings should not depend on how they are presented. We have a division, as we said before, between the UI and how the settings are modeled. Settings. Other thing that we really want to stress is that we have a real modular system where the parts of the module of the system can be loaded independently, and we don't have dependencies that are unneeded. We don't want our system to depend on the settings if it's not extremely required. We want the model, the domain, to just depend on other things of the domain. We have to recall also that to have a nice level of customization, we have to design our component, we have to design our objects to be customizable. We don't need to let it to the last moment, because we have to think all the points of customization and extension in advance. Also, all this customization, all the logic should be internal, and we should be able to expose the minimal possible. Of course, we don't want to have this logic tied to a preference object, and we want to be able to set them from outside. As a conclusion, a good architecture should not use extensively global variables. We have to avoid global variables because they are complex to maintain and complex to test. We also need to avoid singleton and facade because they are patterns that usually are used wrong. And our theory, our position is that the facade is really useful for problems that look like the compiler, when we want to have a single entry point to a place, but maybe it should not be a singlet. And of course, the last point that we talk is that all the customizations should be internal first, and then we should have a way of exposing, but all the questions and all the conditional code about customization should be done internally to the class and the object.